It turns out that so much of what we thought we knew about our own brains, well, it's been completely turned on its head. And honestly, it's one of the most exciting things happening in science right now because it affects every single one of us.
So let me ask you something. Is the brain you have right now set in stone? I mean, once you hit adulthood, is that it? Is it fixed? For the longest time, science pretty much said, yep, it's fixed. The common belief was that after childhood, your brain only changed for the worse. You'd lose brain cells as you got older or through damage, but that was it. No new tricks for the old dog, so to speak.
Well, it turns out that could not be more wrong. The truth is, your brain is in a constant state of renovation. It's always being reshaped. Everything we do, every single day, is physically changing its structure. And the best part, it doesn't matter how old you are.
So, this amazing ability of the brain to literally rewire itself, to learn and adapt no matter what, well, it has a name, and it's the key to pretty much everything. It's called neuroplasticity. And listen, this isn't some high-level abstract idea. It's real. Every single time you learn something new, practice a skill, have a new experience, you are physically changing your brain. So how does that actually happen? Okay, so how does this work on a biological level? I mean, it's not magic, right? Well, researchers have found there are basically three main ways the brain makes these changes happen. We're talking about chemical changes, structural changes, and functional changes. They all kind of work together, but they do different things and work on different timelines, especially when it comes to memory. Okay, so this explains something we've all experienced. You ever cram for a test or practice a new song on the piano for an hour and you feel like, I've got this, and then you wake up the next day and it's just gone? Yeah, that's a chemical change. It's fast, it's short term. Your brain just floods the zone with chemicals to make connections easier for a little while. But for real, lasting learning, the kind that sticks, you need structural change. That's the slow and steady work of physically rebuilding the connections. And here's the proof. This isn't just a theory. We can actually see these physical changes. People who read Braille, for example, have larger brain areas dedicated to the sense of touch in their fingers. It makes sense, right? And get this, London taxi drivers who have to memorize this insane, sprawling map of the city, their brains physically grow a larger region for spatial memory. It's incredible. What you do over and over literally sculpts your brain. And the third type is functional change. The best way to think about it is like this. When you use a pathway in your brain, it's like walking a path in a forest. The more you use it, the clearer and easier that path becomes to travel. Entire networks in your brain become more efficient and easier to activate the more you use them. Okay, so this all sounds fantastic. Our brains are these super adaptable plastic things, but that raises a pretty big question, doesn't it? If they're so flexible, why is it still so hard to learn a new language? And more seriously, why don't people always fully recover from brain damage? Let's take stroke, for example. It's a really tough case of brain injury. But by looking at the challenges of recovery here, we can actually learn a ton about how all our brains work and what the limits of this plasticity really are. And this is a huge deal. We've gotten much better at helping people survive a stroke, which is great, but we haven't been nearly as successful at helping them recover their abilities afterward. It's actually the #1 reason adults have long-term disabilities worldwide. But here's where it gets really interesting for all of us. By tackling this incredibly difficult problem, how to help a damaged brain heal, scientists have stumbled upon some universal truths. Some fundamental rules about how all our brains change, whether you're recovering from an injury or just trying to learn a new hobby. So what are these big lessons? It really comes down to two simple but powerful rules of change. All right, rule #1. And honestly, this is the big one. This is the engine that makes the whole thing go. Here it is from Dr. Laura Boyd. The primary driver of change in your brain is your behavior. There is no neuroplasticity drug you can take. That says it all. You can't just swallow a pill. You can't just passively watch a video. You have to do the thing. And in fact, the research is super clear on this. The more you struggle, the more you have to really work at it, the more your brain physically changes. But you have to realize this is a total double-edged sword. Because if your behavior is what drives the change, that means it works both ways. The very same process that lets you learn a new skill is also what can lock in a bad habit. It's what's behind addiction and even chronic pain. Your brain is constantly being shaped by what you do, but also by what you stop doing. And that brings us to rule #2. There is no one-size-fits-all plan. You've probably heard of the 10,000-hour rule, right? Well, it's just not that simple. The thing is, every single one of our brains is unique. So the way I learn best is probably different from how you learn best. There's no magic formula. So when you put it all together, what does this mean for you? Well, it's actually one of the most empowering ideas in all of science. It means you are, quite literally, the architect of your own brain. I mean, really think about that. Everything you do, everything you pay attention to, everything you experience, it's all changing your brain. Every moment. It's happening right now. And it can be for the better or for the worse. That part is up to you. So the question isn't if your brain is changing. It is. The only real question is, what kind of brain are you building? What brain will you build today?